This resource is the third in a 5-part series on the normal distribution. Part 1 looks at the basics of the normal distribution. We discuss the distribution about the mean and the probability of an amount lying between integral multiples of the standard deviation. Part 2 considers the process of normalizing a value. Part 3 considers the probability a normally distributed value will lie in some range. Part 4 combines the ideas presented in Parts 2 and 3, finding percentages for examples that require normalizing the value first. Part 5 looks at how to find the variable value that define various percentile ranks in a population, which means a specified percentage of the population is less than that value for the variable. Before we proceed, let's begin with a quick review. We looked at the idea of a population within normal distribution, in which most of the members lie within some number of standard deviations of the mean. We then looked at the idea of normalizing a value, scaling the score so that the mean is 0 and the standard deviation is 1. We identified that 68% of the population is within 1 standard deviation of the mean, 95% within 2 standard deviations, and 99.7% within 3 standard deviations. But what happens if our score is not an integral multiple of standard deviations from the mean? That is, what if our z-score has a decimal? When we have a non-integer for a z-score, we will consider the cumulative frequency, which is the percent of the population that has that z-score or less. This percentage, called a p-value, is equivalently the probability that a randomly selected member of the population has that z-score or less. Luckily, there are tables of values to find these p-values for z-scores. A link is provided for one such table. But how do we read these tables? Most of these charts will provide p-values for z-scores with 2 decimal places. First, find the whole number and the first decimal place in the leftmost column of the chart. This identifies the horizontal row of values you will focus on. Note that the chart on screen only has positive values. Most sites and books have a separate chart for negative z-scores. Now look at the column headings on the top to locate the second decimal value. This will determine the column in which our p-value lies. Find the intersection of our row and column to find the p-value. For example, suppose we want to know what percent of a normally distributed population is less than 0.77 standard deviations above the mean for some measurement of interest. First, we locate the row for 0.7. Then we find the column where 7 is the last digit. Reading down the column and across the row, we find a p-value of 0.7794. This means that nearly 78% of all members of a normally distributed population have scores that are 0.77 standard deviations above the mean or less. But what happens if we want to find the probability a randomly selected member of a normal population has a measurement above a given z-score? Cumulative frequency measures less than or equal to, not greater than. Recall that the total area under the curve is 1. So to find the percent of the population above a z-score, we simply subtract 1 minus the percent below. For example, what percent of a normally distributed population is more than 1.53 standard deviations above the mean? To find the probability that z is greater than 1.53, we will subtract 1 minus the probability that z is less than 1.53. Looking up the p-value for a z-score of 1.53, we get 0.937. After subtracting, the probability that z is greater than 1.53 is 0.063. So 6.3 of a population is more than 1.53 standard deviations above the mean for our measurement of interest. What if we want to find the probability that a z-score lies between two values? Or equivalently, what percent of a normally distributed population lies between two values? If we call the lower limit a and the upper limit b, we want to find the probability that a is less than or equal to z is less than or equal to b. To do so, we find the p-value for b and subtract the p-value for a. For example, suppose we want to find the percent of a normally distributed population that lies somewhere between 0.56 and 2.47 standard deviations above the mean. This means we want to find the probability that 0.56 is less than or equal to z is less than or equal to 2.47. To do so, we subtract the p-value for 2.47 minus the p-value for 0.56. Looking up those values in our cumulative frequency chart, we have 0.9932 minus 0.7123, which is 0.2809. This means that 28.09% of a normally distributed population lies in the range from 0.56 through 2.47 standard deviations above the mean. These examples have been very mathy, without any context. How will we approach problems from real-world examples? Stay tuned for the next resource in the series.